All right. So now here's a slab. I'm going to show you the rebar for a slab, which is very similar to the rebar uh, for a wall, right? A wall and again, anything that is a flat surface made of concrete, you can add rebar to it in Revit. Okay. So in my case, I've got a slab. So when I select the slab, now in the case of a slab, it may say, so when I select this, oh, let me close that guy. When I select this, and I don't know, I can't see if it's actually selected. So when I hover over the edge and I select it, notice there is something called as area rebar. Under reinforcement, there's something called area. When I click on that, it says, hey, rebar definitions will include hooks. So the way the American Concrete Institute says rebar should be is when it comes to edges, it wants to have hooks. It doesn't want to have straight rebar. Why does it want to have hooks? It wants the rebar to be completely embedded in the concrete. It wants to be having turned down or turned up with a tiny hook at the edge so that it does not sort of shift over time inside the concrete, right? So it's basically hooked so that it's more stable over there. Now, it says it will include that, and I will just say, okay, I don't have any choice, so I'm going to say okay there. And then it says, okay, where do you want that rebar to go? Now, I can select that rebar to go just in a specific area of the slab, but in reality, I want the rebar to go throughout the slab. Okay, so in that case, I'm just going to say pick lines. Notice there's an option to pick lines right there. So I'm going to select pick lines. I'm just going to select the edge of the walls. So those are the edge of my walls, right? And then I'm going to say finish edit mode, right? Well, actually, no, not yet. So once I'm again, when you have this red X and the green check mark, that means you're in edit mode. You have to finish that operation before you get to do anything else. So while I've got that, I'm going to say, okay, structural area reinforcement. And notice that double line right there. For Revit, that is considered the major direction. The major direction, the only difference between the major and minor direction is this is one direction, that's the other direction. That's all that means. Okay. So now if I look under layers, it says, hey, I'm going to put rebar, structural rebar one. I don't want structural rebar one. I don't even know what that means. Rebar comes in a number. Number 2 bar, number 3, well, there's no number 2. Number 3 bar, number 4 bar, number 5 bar, and so on, right? What does that mean? What's a number 4 bar mean to you? The diameter is 4/8 of an inch. Okay. So a number 8 bar would be 1 inch in diameter, right? So I'm going to say I want a number 4 bar, let's say. So I'm going to go down there and say, make it number 4 bar. And then in the major direction, I want it at every 18 inches. So 1'6". Now, major direction has top and bottom. So you could have rebar on the top of the slab and the bottom of the slab, right? So in the major direction, in the top, let's say I want 1'6". In the minor direction, I don't want any rebar, just for the sake of argument at the top, I don't want any. And then on the bottom, I want both top and bottom, and I want a number 4 bar. And then I want it at 1'6" in the major direction, and then number 4 bar, let's say at every 2 feet in the minor direction. So when I hit finish, it puts rebar in there, right? So again, if I go shaded, I won't see it. But if I say wireframe, notice now I see all the rebar. Also in 3D, I could do the same thing. Now, if you zoom in closer and further away, it would sometimes try to flick between showing you or not showing you. But here's the rebar. So in the top, again, we can't clearly tell how far apart they are, but we just know that they're there. Right? That's how you do area reinforcement. Instead of doing 1 bar at a time, I just did what we call as area reinforcement. Right? Now, Let's go back to fine and shaded. Now, what if I wanted to do rebar on my wall? Rebar would look the same, except it would say interior side, exterior side. Instead of top and bottom, it would say interior side and exterior side, and same idea. Add whatever size rebar, however far apart. One direction would be major, the opposite direction would be minor. Okay. Now, as far as drawing rebar for a foundation, for a, let's say, I'm going to take this guy and then I'm going to say, one of the options in Revit is to isolate this element and then hide everything else, right? So I'll select this item, and then where it says, where the glasses are there, I'm going to click on that and say isolate element. So notice how everything else is hidden, and I get to model just in this one space, right? So I can select this guy, and then I can say rebar. But that's not the best place to do rebar. If you want to do rebar for this, I want to go in here, and then I'm going to cut a section. I'm going to cut, let's say, this section right here. And instead of seeing everything, I just want to see up to that point. Back to you shaded. Let me select this guy. How do I select that foundation without selecting everything else? What do you think? Hover over it, push the tab key until it lets you pick that element. There's that element, and now I can isolate it. I can select that glasses and say isolate element. So now everything else is hidden. So now let me cut a section through that. Go to view. So there's my foundation. I can select rebar, and then notice it's trying to put one rebar. And if I hover on, if I change from parallel to work plane to parallel to cover, notice now it's going as a dot, as in going in the opposite direction. I could also change it to perpendicular to cover, and try these different options to see what all options that it's giving you. Right? And if I want it to be horizontal and it's not, there it is. There's the horizontal rebar. But do I want to do one or do I want to do multiple? Right? So let's say we're going to parallel to cover, and then instead of, notice where it says single over here, I can change that to maximum spacing, and I can say, hey, I want it at every 8 inches. And then I could say, I don't want structural rebar 1, I want, let's say, a number 6 bar. And now if I hover over the vertical side, it tells me, hey, this is how many bars I can put in. But if I hover over the horizontal side, it tells me how many rebars I can put in. That makes sense? All right, so I'll put in one over here and put another one, say, over here. And now when I go back and look at my L1 and then look at, let's say, wireframe, notice how it put rebar up to there. So this is the step part. But I don't want it to do for the step part, so I'm going to just stretch it back to somewhere over here. Well, let's stretch it back even further. Well, we can fix it. Don't worry about that. And now I'm going to drag this section this way. And then go back to that section and then add rebar again. Right? So I'm going to say, select this guy, rebar, maximum spacing of 8 inches, parallel to cover. And then I go number 6 bar again at the top left. So I go, I want some over there, some over there. Right? And now what I could do is go back in here. So now it's got all the rebar, but it's not all at the right place. How do I know it's not at the right place? Well, let's cut this section, take a look. And I don't want to see all the way. I just want to see just for this guy. And then if I right click on it and go to view, notice what it's showing me. So there's rebar up to there and rebar up to here. But what we really want is a transition between the two, right? We want a transition between the two so that the stress can evenly be distributed. So this is how we're going to do this. So let's say I've got rebar over here. So I'm going to take this guy, pull it back up to there. Take this guy, pull it back up to there. And my goal is to see if I can draw a piece of rebar that goes from here and then follows this slope, right? In order to do that now, I'll select this element again, rebar. This time I'm going to select maximum spacing 8 inches, but this time I'm going to select sketch rebar. Notice sketch rebar. So instead of drawing a straight line or putting in one at a time, I'm going to sketch the rebar, and then I'm going to select, yeah, this is the element I want to sketch the rebar for. Current work plane. Well, I guess I better cut it through that section then. So notice how when I cut this section, I didn't cut it on the member. If you don't cut it on the member, it says, where in this work plane do you want me to do it? So I'll have to move this section directly on top of it, and now it won't give me that option, or it won't ask me that question. So again, select that guy, rebar, sketch rebar. It knows now where it needs to do it. So I'm just going to draw one. Oh, select it, rebar, sketch, select it again, and now you're in the drawing mode. Notice the red X and the green check mark. That means you're in the drawing mode. I'm going to select that guy to there. Okay? And then finish it. But that's just one piece of rebar. Well, we can select that guy and say, hey, I don't want single. I want a maximum spacing of 8 inches. Right? And then I can select this again, rebar, sketch, select it again. Now I'm in the drawing mode. Now I can draw a piece of rebar from there to, again, I'm not doing it accurately. The reason I'm not doing it accurately is because I have to draw some reference lines and then get the slope the same as my other one. And as long as I'm able to do that, then I can draw it, right? How do I draw a reference line? Well, let me finish this and well, let's actually get it accurate. If I want to hide floating meeting panels. Let's escape out of this. Every time I hit escape, this thing starts to show up. Does it show up on your screen? Yeah. So let's select that, delete it. Let's draw a reference plane. Notice I'm drawing a reference plane like so, right? And now I'm going to take that reference plane and join it over there. Okay, there's my reference plane. And then I'm going to finish this. I'm going to cancel out of this. That reference plane will still be there. Wasn't there. Okay, let me draw a reference plane over here without any of these. So, okay, that's the slope. Let me carry that over here, attach it over there. Let me copy that, Control C, Control V. And well, let me do that rebar first and then I'll draw it for later. So let's take that guy and stretch it out over there. And now select this rebar again, sketch rebar, select it again, go from there to there. So now it follows the slope. It follows the slope of that. Again, it doesn't join, so I'm going to make it join. Again, make it join. So it follows that slope. And then I can finish that. And then after finishing it, I can say, well, I don't want one of those. I'm going to select that guy. Instead of single, I'm going to say maximum spacing of 8 inches. Right, so if you're looking to make it exactly the same slope as that one, and then I can delete that reference line. So you could do it that way. And now when I look at 3D view and look at what my rebar looks like, let's go to wireframe and notice what this looks like. It kind of looks like it's supposed to, right? Questions about rebar? Yeah.
So for the other program we use to like look at it and then build it in this, how do we see in there?
Just that one. That's a good question. That I don't know. Well, I'm gonna create some views with just the 3D view with only hidden lines. That way you can look around it.
Like you don't want it in the wall line.
I want it in the wall, and I don't want it to be precise as I've done it as much as I want it in the wall.
But on the sound from the other day, you wanted an out?
Yeah, but no, not the other day.
Yeah.
So here's what's going to happen. Sorry, yes, continuation of that assignment. So the second assignment that I've posted is basically built on top of that first one. But that assignment is not due until Thursday. The one that we're working on everything I showed you the other day, that's due on Tuesday. What I'm showing you today is due next Thursday. And if there are questions, we can answer it on Tuesday. Question?
For the rebar overlap, do we design it with an overlap or?
It automatically does the overlap, and it also takes care of the cover. So don't worry about that. But essentially, you could draw any rebar, overlap everything the way you want to in Revit. But you will hardly ever find engineers drawing rebar in Revit. Why? Because it's typical, right? So if I do the rebar for one foundation, it's the same rebar for all the foundations, right? So I just draw rebar for one foundation, make a detail out of it, move on. I'm not going to draw rebar for every foundation. In the case of construction drawings, because nobody's looking at the model for rebar. Everybody's looking at the detail for rebar. Questions? Let's take a look at how to do a custom slab edge. So we haven't done this part before. If you want to do this, there's a thing called as developing your own family, right? Family, for lack of a better, I guess Revit came late into the picture. And instead of calling it an object, because that was taken up by many other programs, BIM programs that were before Revit, they started calling everything a family. Okay, but it suffice to say that they're interpreting that word as an object. So if I want to create an object that is a custom slab edge that I want to use on my slab, first of all, on my slab, if I wanted to create a slab edge, so let's reset this 3D view. Click on that and reset temporary hide. We see everything. Let's say that we go to shaded again. So there's my slab, right? Let's look at it from the top for a second. So there's my slab. If I want to do a slab edge, When I click on that, notice there's a floor slab edge, right? If I want to select whatever is the default one and then go click on the edge of a slab, notice how it's highlighted when I go to the edge of a slab and I click on it, it puts it down there, but it doesn't put it exactly the way I want it. What do you mean by that? Well, let's cut a section, look at it. Oh, can't do it in 3D view, sorry. So let's reset this view and go to wireframe to shaded. So now if I want to cut a section, and go to that view, you'll notice how this is the slab edge, but it goes in with the top of the slab. Well, a slab edge needs to go with the bottom of the slab, so I'm just going to drag it to the bottom. That's what a slab edge should look like. But what if this is not the shape that I want? If I want a custom slab edge shape, how would I do that? Well, in order to do that, you would do something like this. So this is like a 2 or 3 step process, right? So you would go to File, New, and again, I am not going to show you how to create custom families in Revit, except for the 2 things that we're going to do today. Okay, we're not going to create any custom families. But suffice know that you can create Revit, even though it's supposed to be a, it's a BIM program. You need to be able to create whatever type of objects that you can create. And the short answer is yes, you can do all those things. However, the other answer is maybe we don't want to. We want to use whatever's already in Revit. And then if you have a situation where something, 2 parts of a building are meeting in a weird way and you're having trouble seeing it, suffice that to know that you can pick up the phone, call your architect and say, look, I'm not able to communicate this really well with everybody that needs to work on this. Can you give me a custom family that shows everything that's going on here, right? And the answer to that would be, yes, I can. And if that's not the answer, you can, if you don't get that answer, you can inundate them with RFIs and still get them to do what you want them to do. Because again, if you're not able to see how they wanted to build it, how they want you to build it, you're gonna have to make some assumptions, right? And that's a problem. As a builder, you don't want to make assumptions about the model. Why? Because the architect may say, that's not what I drew. Now you're gonna tear it up and redo it, right? So, okay. So if you wanted to draw a custom profile, here's how I would do it. I'd go to File, New, Family. Okay. All right. Let's save the project. File, New, Family. I'm going to scroll down and then I'm going to say, I want a profile family. A profile is, for the lack of a better term, it's a silhouette. I'm just going to draw a silhouette of what it looks like when I cut a section. Okay. So I'm going to say open. And now, as far as slab edge families are concerned, I'm going to do it in the 3rd quadrant. Notice there's 1, 2, 3, 4 quadrants. I'm going to do it in the 3rd quadrant because that's what makes it come in correctly. So let's say I want to go 2 feet wide. I want to go, let's say, a foot deep. I want to go 1 foot again this way. And then I want to go, let's see, 45-degree angle and then join over here. And then I want to go up and then finish it. Okay, that's my slab edge. Custom slab edge. You could draw any shape that you want. Again, these are all the typical drawing tools to draw curves, arcs, anything you want. So let's say this is what I want. And then I'm just going to, before I put it in, I need to be able to add rebar to my slab edge. Sometimes slab edges have rebar. So in order to do that, I'm going to say, go to Family, Category, and Parameters and say, hey, this profile usage is not generic. It is going to be used as a slab edge. And the material model doesn't matter. You can change it to concrete if you like, but it's a slab edge tells it that I can add rebar to it. Once you do that and say okay to it, now you can load into project. Or you could also load into project and close. Now, the difference is sometimes people like to save their families. This is one of the reasons why architects are reluctant to give you their models. Let's say they have some custom families in there. There's no way for them to give you the model and you also not get the family. They're transferring their intellectual property along with that model. That's one of the reasons why people are not interested in giving their model, or at least reluctant. They used to be reluctant, but architects shouldn't worry about that because unless you're giving it to another architect, you're not really giving it to a competitor, right? I mean, if a structural engineer gives a custom family to a mechanical sub, what are they going to do with that? Right? That's not their major business, right? So I would go ahead and load into project and close. As soon as you say load into project and close, it says, do you want to save the family? I don't need to save the family because it's already going into the other one. As long as it's in the model, I don't care. I can always extract it if I wanted to, right? So I don't need another copy of it. So I'm going to go ahead and say no. And now notice how we drew that slab edge over there. I'm going to draw the slab edge on this side now. So select slab, slab edge. Instead of the select that one, I'm going to edit type, duplicate, call it my slab edge or something. And then where it says profile, change it to family one. Notice now there is something called as family one because we told that profile, hey, it's going to be used as a slab edge. So when you load it into this project, it's going to show up in here, right? And then I'm going to say, okay. And then let's just select that edge and let's cut a section, look at it. It's there, but not the way we want it because we want it to be over here. Right, so that's a slab edge. Now, when I select this slab edge, notice I have this option to do rebar. If I had not said it's a slab edge, I would not be able to say I'd be able to put rebar in it. Right, so that's a custom family. By the way, I told you all that if I get a model, I have all the families that are used in the project are available to me in this model. If you scroll down, one of the options that you see is families. So anything that's, again, they're all the families in Revit, but one of the options here should be profiles. And there's all these profiles, and amongst all of them is that family one. So I can open that family one and say, hey, open that. If I wanted to extract it, all I need to say is edit that family, and then it will bring me back to where I started. I can edit it, save it. So this is what I mean. When you're giving a model to somebody, you're also giving away any custom families that you have to that other party. Anyway, we'll close that guy. Now, I'm assuming everybody knows how to draw beams, right? How do we draw beams that are open web steel joists? Again, we may not have done it, but notice there's this thing called a beam. So if I want to, let's say a 21K6, a 21K6 is a bar joist, which has a name, 21K6. So I don't see it in here. So I'm going to go, well, what do you mean? These are all the beams that are loaded in here, but I don't see a 21K6. So I would go to load family. Well, cancel out of that first, modify, insert, load Autodesk family. And then I would go to all results, structural framing, steel, and then scroll down to bar joist. There should be a K-series bar joist. So there's a K-series bar joist round web. Select that, load, and then you can go down to 21K6 or 22K6, let's say. And then if you also wanted to pick up, let's say, a 26K7, you can hold your control key down and then select that and select multiple ones, whichever ones that you need, and then say OK to that. And when I select beam this time, notice I have a 26K6 or 22K6 and a 26K7. So if I wanted that 26K7, again, I don't want it on level 1. I want it on level 2. Let's go up to level 2. So beam again. Whichever one was the last loaded beam is what will show up. So there's my beam. And in my 3D view, here's my beam. Right? So there's my bar joist. Now, if I wanted to draw a brace, what's a brace, by the way? So when you're walking around Gorey Center, you will see a lot of X braces, K braces, and so on that are exposed to the outside. The reason they're exposed to the outside, we wanted to show people what the brace looks like, what the purpose of it is, and what have you. In the case of steel buildings, well, in case of all buildings, they have to resist lateral forces. These lateral forces are typically lateral, meaning in the X direction. Gravity goes in the Y direction. Lateral forces, wind, earthquake loads are in the X direction. And in order to resist X direction forces, we have to convert the X direction forces into Y direction. Does that make sense? We have to convert X direction forces into Y direction. Well, how do we convert X direction force to Y direction? Well, we could do that when we have these diagonal members. So when wind hits the side of the building, this diagonal member goes from top to bottom, and it will convey that force to the bottom. A lot of times you'll see X braces. Those X braces are to say, if wind hits from this side, this will take the load. If wind hits from that side, the other side will take the load. Right? So that's the purpose of braces. So if you want to draw a brace, I'm going to show you how to draw one brace. Let's go to L1, select brace, and by default, it'll pick whatever was the last beam used. I don't want a K-joist for a brace. So I'm going to select, let's say, a W8 by 10. And then, again, it's a brace. I'm drawing it on level 1. So I'm going to go, hey, I want to go from there to there. Just like a beam, I'm drawing it. But if you look closely, I drew it as a beam. And then if I go to 3D view, it's just showing on the ground. Well, that's not really a brace. But select it, and now you have some options. So when I select it, notice that it says the geometric position says it goes from L1 to L1 with 0 offset. Well, I want to go from L2 to L1, and then the attachment offset is 0. So now it'll go from L2 to L1, and notice now I have a brace. Right? That's draw like a beam, and then change the offset. So again, the options are start attachment, end attachment. Start attachment, if you look at the whole thing, it's kind of cut off, but it says start attachment level reference, end attachment level reference. And you can go from L1 to L2 if you like, L1 to L2 and make sure that these are 0 offsets. And hit apply, and notice now brace goes in the opposite direction. Right? You can control the brace, which direction it goes by doing that. Now, what's the last beam I used? It was a W8 by 10, right? So let's say if I want to draw a truss, I go to level 2 structural. It won't let me draw it in architecture, but level 2 structure. If I want to draw a truss, so in structure, I select truss. Notice there are a bunch of trusses. So that's the only one that's loaded. So I might need to go to Insert, Load Autodesk Family, Steel Framing, or all trusses, or all members, and then go to Structural Trusses. Notice all the different types of trusses I have. So let's say I want to do a simple Fink truss. Select that. And L2 Structural. Go back to Structure. And I'll select Truss. This time, whatever I just loaded will be showing up. And then I'll just draw it from there to there. Right? Elements have duplicate type marks. Don't worry about that. Type marks. Anytime you see the word marks, that means it's annotation, labeling. We don't care about that. Go to 3D view. There's my truss. I drew it on level 2. That's why it's showing up like that. Now, trusses won't show up perfectly. As in, notice how the connections are kind of jumbled up. But it's a representation of what it's going to look like. This is a construction drawing, not a shop drawing. Right? So don't worry too much about that. But what if I wanted to draw a custom truss? What if I wanted to draw a custom truss and I want it to be made of 2x4s or 2x12s, let's say. So I'm going to go, so this is the other custom object that I was going to show you guys today, which is go to File, New, Family. And then you can scroll down to Structural Trusses. Let's hit open. So right now the truss length is 80 feet. Well, let's measure. Again, this is a custom truss, so I want to measure exactly how much distance I want the truss to span. So I'm going to use that measure tool in Revit. Notice it says measure between two references. Click on that. So from there to there at a 90-degree angle, it's 65 feet, 229 over 32. Let me change that. Let's move that guy. Let me dimension it first. Annotate, line dimension. So click on that and change that to 65. So now it has moved it to 65 feet. So we're good now. So now I'm going to draw a truss that is exactly 65 feet. So I'm going to say, hey, I want the truss length to be 65 feet. So notice how that line came back in. A truss has a top chord, a bottom chord, and diagonal members, right? Any truss has top chord, bottom chord, diagonal members. And notice in the Create tab, they're showing you top chord, bottom, and web members. I call diagonal web members. So top chord, from there to there. Bottom chord, from there to there. Web, from there to there. Another web, from there to there. Maybe another web, from there to there. Okay, I'm done. So I got top chord, bottom chord, web members. I know exactly how long my truss should be. That's the main thing about creating a custom truss. I don't want it to be, you can create what is called as a parametric truss, meaning it will automatically adjust based on the length. I don't want to mess with all that right now. Just make this truss and then let's load into project and close. Oh no, cancel. Load into project and close. I don't need to save the family. So now when I select structural truss, it will come in, but it will do it same with that 8x10. I don't want the W8x10. I said I wanted a 2x12 truss, right? So let's load a 2x12. So let's go to Insert, Load Autodesk Family, All Results, Structural Framing, Wood, Dimension Lumber. Let me select a 2x12. Say OK. I'm just going to go ahead and draw a beam just for the sake of it. Notice the 2x12. Why do I want to draw a beam? I'm even going to delete it. Once I've drawn it, it doesn't matter. It's somewhere in the 3D space. There's that 2x4. I'm just going to delete it. Why? Because anytime you draw a truss, it will use whatever was the last beam you used. Okay? So if I go back to my L3, level L3, and then I want to draw a structural truss of family 2, and I say it goes from here to here, and I look at it in 3D view, you'll notice that it used that 2x4 to draw that truss. Now, what if I want the truss to do the other side? Well, you could do it by doing this. Notice last time I started at the bottom, went to the top. What would happen if I started at the top and went to the bottom? There you have it. Questions? Nobody's asking any questions. I'm assuming everybody's like, got it. Got it. No problem. Do what now?
That would be a wrong assumption.
That would be a wrong assumption.
Okay, got it.
Question?
There you can see what kind of rebars, but it doesn't tell you where.
Eyeball it. Yeah, I'm gonna give you a section view with I'm gonna create another 3D view, which has got a wireframe view. So as long as you have rebar in there, I'm not that interested that you have the exact rebar at this exact same place.
So you don't care if it's like number 6 or number 4, this is just.
Not that interested, yeah. I just need you to know how to open a model and look at what rebar is in there. And you can't do that unless you've drawn a couple of pieces of rebar. I want to get out of modeling as quickly as I can so that we can get into what you're actually going to do as far as coordination, using Navisworks and that sort of thing. Because that's really the tool that you get to use the most if you go into the industry, using Navisworks for coordination. What trades are running into each other? How do we deal with that? And all those kinds of good stuff. So we'll do, I mean, this is probably the heaviest modeling we're going to do. From now on, my goal is to try to minimize how much we do that. So we can spend more time doing estimating, doing. That's not to say that part is going to be easy. That part is also equally as complex, but at least that'll be the stuff that you're going to need to know how to do. But in order to do that part well, you need to understand how it was modeled in the first place. Questions about everybody's finished the first assignment?
The foundation walls,
Foundation wall is the problem.
that's that foundation.
Yeah, so I would recommend even do some YouTube videos on how to do that, and they probably explain it better than I did. But they're going to go through the same thing, which is draw a wall and then edit the profile of the wall.
It's just not user friendly.
Once you get the hang of it, Other questions? How many of you are TAs in here? Okay. I'll show you something. I'm sorry, it's not for everyone.
Close your eyes.
It's not close your eyes, but for the rest of you, you're gonna have to pay for it. So when you go to AU Access under employee, right, you'd scroll down to employee resource tools. And one of the options is LinkedIn Learning. Auburn pays for you to have LinkedIn Learning. And let me log into my LinkedIn Learning. Again, we're not doing anything that requires you to know LinkedIn Learning, but if you ever wanted to say Revit 2026, well, there's essential training for architects, or let's do Revit 2026 structure. There is Revit 2025 essential training for structure. That'd be pretty close to Revit 2026 as well. So it says imperial and metric. So when you click on that, now notice it's got like a 8-hour whole class on how to do different things. So, you know, if you want it, there should be somewhere in here about rebar. Reinforcing. Again, let's see, the whole thing is about maybe 30-minute videos. But if you are interested in sort of doing this, you know, it will take you to that place and then walk you through the video. But anybody that's a TA has access to it. If you're not a TA, you can still get access to it, but it's like $34 a month or something like that. But it's a great resource, and it's not just, it is not, I've been lobbying the administration, Sanford Hall, for at least 10 years now to make sure that all students have access to LinkedIn Learning, but it's about 30 grand a year and they don't want to spend that much money. Well, it's not really, because, you know, their IT budget is it's in the tens of millions, and I don't know why they don't want to spend $30,000. It's like, well, what are we going to cut if you're going to do this? And I'm like, somebody's salary, maybe? But I don't, if you're ever in here, you know, for most of you, you may not want to do the Revit and all this, but you might want to learn something different, right? You might want to see what's there for, say, artificial intelligence, or what's there for project management, or what have you.
Let's say good laptops for every master's student. So that's 37.
Yeah, that's unlikely to happen. In fact, I can see a scenario where in the very near future, where these computers labs will go away. And the reason they'll go away is because imagine that Windows app that we were using yesterday that was so slow. Imagine if it were as fast as watching Netflix at home. And your Netflix doesn't flicker at home. It's on the internet. It's not coming through your cable, right? Imagine if you have that kind of connectivity, you're not going to need laptops. You're not going to need anything. Everybody can bring their own device. It could be an iPad. It could be a laptop. You connect to the web. Everything's out there. So that's where we're headed. So in the very near future, I suspect that it's going to be bring your own device, whether you go to work, school, what have you. Because if you ever work and they gave you a phone, it's a bane. You may think it's cool that they're giving you your phone, but do you guys have personal phones? There you go. He's got 2 phones in his hands. And it's because obviously you don't want your personal messages and all that on your work phone, right? And you can't be tied to your work phone, because what if you change jobs? You're gonna tell everybody you're gonna change your phone or your number, and then everything has to port over. So anyway, it's gonna be this. That'll be the reason why we're gonna go to everybody bring your own device. Thoughts, questions? Has there been a change in the schedule? I don't know if you guys have looked at it. I had the schedule to where we did not have class on the day of the career fair. But we now have class on the day of the career fair because the career fair is over at 2 p.m.
But I've got a meeting set up.
Meetings, all meetings are next day. All the meetings are the next day, Mia. The career fair is from 10 to 2 and one-on-one meetings are the next day on Wednesday.
What if I'm sick?
You can't be sick. I need a doctor's note. Other questions? So, when we come back on Tuesday, I have nothing new to cover other than do any kind of hand holding that you need to finish the assignments.
When does he get both of those?
What? I tried to do that.
He's like-
He lost that.
You're walking with no.
Oh, yeah, you probably, he did everything that is because of. Right. Again, on the. Yeah. Yeah, you know, this. This section. That's me, that's.
Yeah.
Oh, I did. Section, a lot of people.
Hey, you going home this weekend? Me?
No, I don't think so.
Okay.
Oh, it's a weekend today, right?
Yeah.
The way they try to do the section sort, it's just like not.
Okay, section views don't work.
Say
in
that,
any-
like, no.
You can only cut a section in 2D.
Yeah. When I'm Charles on the street somewhere.
So now notice that.
That makes so much sense. I was like drawing that, I was talking to pretty trying. Okay, thank you.
We're gonna have
Well.
the machine running by the weekend.
All right.
Got a Jason Bronco, right?
Ready?
Change.
Is it lunch?
That's like, oh, she can't stop. Oh, there's Bronco. Cause every time I think of a Bronco,